to take this 49.
Wait, so what about the top?
Oh, minus x squared. What about the top? What do you mean about what about the top? Greater than or equal to 0. Solve. Okay, I wonder if I could try to do this with the text.
There's always me, though.
This one, set the denominator equal to 0. Why? Because you can't have a 0 in a denominator, right? So because we say, well, the denominator is not allowed to be 0. So we're going to set this equal to 0. X squared plus 3x. The denominator can be a negative. The denominator can't be 0. Inside here cannot be negative. That's why we say this has to be positive. Greater than or equal to 0 means it has to be positive. This one we know the denominator of a fraction cannot be 0. So we're going to set it equal to 0 and solve and say, well, it's not allowed to be that. Right? So the people that were here on Friday, everybody knows how to factor this, right?
I wasn't here.
I know, that's why I said pair up with somebody who was. You're going to do this, right? Okay, try it. Try it. I'm coming. What did you get for your answers? Anybody? Did you get an answer for this? Okay, 7. So when you solve this, you should get x, and then it's like greater than or equal to 7. Now, when we solve a radical, we actually get a plus or minus. So what happens, remember when we first did this? We said that have negative 7 squared, it's negative 7 times negative 7, which is 49. If I have 7 squared, it's also 7 times 7, which is 49. So when we're doing the reverse, and taking the square root of 49, we... Noises, voices. Are you explaining?
Maybe the slightest noise is like.
So, thanks, Kevin. So we get plus and minus 7 when we take a square root, because initially when we squared something, it could have come from either one of those possibilities. Now, when we have, I'm answering your question, when we have, most of the time when we do a square root, we're usually just saying the positive one. That's called the principal square root. Okay, and many times that's the only thing that you need. But when we're solving an equation like this, you do need both of them. So, because what we're saying is, what numbers can I put in here to make the equation true? And what we found out is basically between negative 7 to positive 7, any number that I pick, negative 3.5, positive 4.5, if I put any of those numbers in here, this will still be a positive number that I can take the square root of and get an answer. And does that help? So that's why we put it has to be greater than or equal to 0. And then we solve, we get both. So this is what we're saying the solution said. The solution said is
what's that plus and minus?
Between negative 7 to positive 7. How do I write between negative 7 to positive 7 in interval form, class?
Is it open or closed?
What do you think, open or closed?
Close.
Closed. Okay, because we're including them, right? It can be 0.
Yeah.
So we're going to say the answer is between negative 7 to positive 7. And that's the solution, right? That's the solution. Okay, how about this one? We said that the denominator is not allowed to be 0. So, who remembers how to factor from Friday? You were here factoring on Friday. But just raise your hand if you were here Friday.
I was here Friday, but I was out of it.
Most of you got this pretty good. So let's rewind and let's review. We're going to set it up so that we have the parentheses, right? What we want is we're going to factor it like this. We want two numbers that multiply together to be 18. Rob, what are two numbers that multiply together to equal 18?
Excuse me?
So what times what equals 18?
9 times 2.
Do you agree?
Yeah.
Okay, how about another pair? 6 times 3. Okay, now I made a mistake. I should have put negative 18. So I'm going to have a negative something here. I also wanted to add up to 3. So 9 minus 2 or 2 minus 9, that's not going to be 3. But 6 and 3, I could do 6 minus 3 or 3 minus 6. Which one is the correct way? The first one, right? So I want the 6 to be positive, and I want the second one to be negative. The minus 3 is negative. Okay, so check. 6 times negative 3. Are you with me, Nasir? Because you were asking. 6 times negative 3 is negative 18. 6 plus negative 3 is positive 3. Right? So then I finish solving by saying these each could equal 0. So my answer is x equals negative 6 or cannot be negative 6. We're saying it cannot be that number because if it were, it would make the denominator 0. So it cannot be 6 and x cannot be 3, right? Negative 6 would make this 0. Negative 3 or positive 3 would make this 0. Correct? Good? Stephanie, how do you feel about that?
Is that all you have?
I'm still not really understanding. I can't see. So what's the answer?
I don't know, I have both of you asking a question at the same time. AJ.
Is that all you have to do for that problem?
That is all you have to do for that problem. It's asking for the domain, so we're only looking for those x values that are restricted. We said that the denominator cannot be 0, so when the numbers that make it 0 are the ones that we have to eliminate. They're a problem. What does rate of change remind you of? Slope. It reminds you of slope, okay? So when we have a straight line has slope. And we remember that the slope is the change in y over the change in x. Okay, we have the change in y, or rise over run. Okay, let's take a look at how this works in this question. So you have, how much does x change from A to B? We're going from A to B. We're looking at the x change only. The x changes 1, 2, 3, 4, 5, 6 units, positive 6 units. How much does y change from A to B? Right, we're going up 4 units, so it's positive 4 units. Now they're saying, what's the slope?
4/7.
So remember, we're doing the change in y over the change in x. So we're going to do the y's over the x's, which is 4/6, and it simplifies to 2/3. So what's the average slope?
2/3.
Still 2/3, right? Because if I went halfway, the average slope is still 2/3. I could go another halfway and it's still 2/3. Or even if I went 1 unit, that would be 2/3 increase per the 1 unit horizontally. Okay, so we are familiar with slope. We're familiar with average. And we're kind of combining the idea now. So this is a pre-calculus topic, as I said yesterday, because a lot of the calculus work that we do is involved with an instantaneous rate of change. So we'll see how they come around to doing instantaneous rate of change. Any questions on this before I turn the page? All right, we're going to go to the next page. Okay, so we're going to circle the points A and B. Or you can use a highlighter. You have highlighter. Okay, there's our 2 points, A and B. And we're kind of going to think of this as straight line slope. Okay, we're looking at still average rate of change. You can think of it as being like the slope of the line between those 2 points. The x change, how much does it go horizontally, is 2 units. Positive, right? Let's keep track of positive and negative. How much does y change? Can we have the voices off, please? Positive 2 units. So again, average slope, you're doing the change in y. Somebody is continuing to talk and you need to stop. 2 over 2, thanks, Joel. Okay, so it's just 1. So between points A and B, our average rate of change is 1. Now what's interesting is we have a curve really instead of a straight line. So as we go through this, you'll see that my results change depending on the points that I pick. Voices are still going. Let's have the voices off, please. Okay, circle the points A and C. Again, if you want to sketch the line that goes through those 2 points, we're basically finding the slope of that line. So how much does x change from A to C? We're going over 1, 2, 3, 1, 2, 3, 4 units, positive 4 units. Y change, 1, 2, 3, 4, 5, 6, 7, 8 units up. So the y changes 8 units positive. The average slope, again, we're doing the delta y over the delta x. So 8 over 4 is 2. And we can see, again, the points that I choose make a difference in how the slope is now that I'm doing this function. Okay, circle the points B and C. Okay, so we're going between here and here. You can sketch a straight line through here to see basically the slope through this line is what we're looking at. How much does x change between B and C? We're going horizontally 1, 2 units. And we're going vertically 1, 2, 3, 4, 5, 6 units. So we're going up 6 units. So the average slope again is the change in y over the change in x. So the y change was 6. The x change is 2. So our average rate of change is 3. Okay, so very different results depending on which points we pick. We got one where the average rate of change was 1, one where it was 2, and one where it was 3. All right, so this is the most important section here now. We talked about this 2 days ago where we defined the average rate of change for a function. If you notice that the average rate of change for a function on the interval, okay, notice that this is an interval and not a point. We're saying the interval from point x1 to point x2. Okay, so we have values on the x-axis. But how does this formula relate to the slope formula? Well, 2 things. One, we know by definition that f of x is y. So if we have, for example, a table like this, g of x and y are interchangeable. But the other thing that we know about f of x is that if we have the notation like this, f of x2 means the function calculated when x equals x sub 2, okay, where this is a number, where x sub 2 is a number.
My personal space is being invaded.
So if you look at this first example, we actually have f of x being defined as a function on this interval, okay, so the interval from x equals 7 to x equals 10, right? So we're going to substitute the values x equals 7 and x equals 10 into the function for the top part. So we're literally calculating the f function twice. The denominator, we're just subtracting these two x values. Okay, so I'm going to write this out here. So the f of x2 in this case is going to be f of 10 minus f of x1 would be 7, right? So this is going to be my x1 and my x2, right? That's my interval. And then in the denominator, I've just got x2 minus x1. So I'm going to do 10 minus 7. Okay, so then how does this look? I have to calculate out the values of these functions and then subtract it. So I'm going to put in 10 into this equation. So I'll have 10 squared minus 4. If you don't mind, I'm going to go ahead and calculate my denominator is 3. I'm also putting the x1 into the function. So x7 goes into x squared minus 4. This is 10. This is a 10 right here. We're using the x values. The x values given to us here on this interval, 7 to 10. Okay, so and then I put it like this just to show you that this is what I'm calculating, and then I subtract the two functions. Okay, so that's what it's saying. I'm subtracting whatever I get when I put the first number in and the number that I get when I put the second number in, and then I subtract them. Okay, so 10 squared minus 4 is 100 minus 4, or 96. Sorry, that's a 9. Weird looking 9. 96. And then my second function, 7 squared, is 49. 49 minus 4 is 45. Okay, so then to finish, I have 96 minus 45 gives me 51 over 3. So 51 over 3 is actually 17. What questions do you have on that?
None.
Wonderful. Thumbs up if I can move on. You guys are ready to move on to the next example? Okay, so this one again, we're finding the average rate of change for, this is an interval, okay, from x equals -5 to x equals 3, right? So if that's the interval we're looking at these 2 points. And we're going to just subtract now, because really in this case, all we're doing is the g of x. G of x is y. So we can think of these as y2 over y, change in y over the change in x. Right? Oops. Wrong. Don't write that down. Oh yeah, I guess I could have written it down. 3 minus a -13 is what I wanted. 3 minus a -5. This changed to a plus.
Wait.
16 over 8. Thank you. So we have an average rate of change of 2. Wait, what questions do you have on that one? On this third example, we have interpreting. We're interpreting. Please remember that anytime they say interpret, you are writing sentences or a sentence to describe what's happening in context. Okay, so they're going to give you the context down here. But the first thing that we're going to do is we're going to interpret, we're going to calculate this. So we have this interval, again, from when x equals 2 to x equals 4. We have 2 to 4 on this one, so that's when x is 2. We're going to look at our x's. We pick the x is 2 to x is 4. Same idea as with slope. We're looking at our change in y over change in x. So we're going to subtract these two. Really, I should be putting like change in p of x, right? If I was really correct. So in this function, we have p of x. So it's not really y, but we think of it as y in this problem. Okay, so change in the vertical values versus the change in the horizontal values. I'm putting the larger number first, or we're doing x2 minus x1. So 32 minus 12 gives me 18. Sorry, 14. 32 minus 14 gives me 18. Add 4 minus 2 gives me 2. So my average is 9. Okay, so now they're going to say, interpret this. In other words, describe. What does this mean? Write a sentence. This average rate of change of p of x models the number of microbes. Okay, so p of x is the number of microbes in hundreds, so they're telling you the units, in a petri dish after x hours. So it's important that you notice what is the y value representing and what is the x value representing. Okay, so x is the hours under a heat lamp. P of x equals the number of microbes. So when we're interpreting, we say it's P of x per 1 unit of x, okay? Or we can say for each unit of x, or for every unit of x. But the denominator is sort of that invisible 1 unit of x is what we're considering. Okay, so notice that this 9, we could write it as 9 over 1, right? So for each 9, 1 unit of x happens. So how I'm interpreting this, I wrote for each, what's the x? Hour, right? X hours. So for each hour under the heat lamp, what happens to the P of x? Yep. The number of microbes is our P of x. So it increases, and we use increases because 9 is positive. Okay, if it was a negative value, we'd say decreases, but it increases by 900, and it told us that they were hundreds, so that's kind of what I'm putting as a unit, 900. Okay, questions about that? How do you all feel about that one? I'm going to let you finish writing. Thumbs up if you feel okay about that and you're ready to move on. Okay, I got 2 responses. Anybody else? Okay, good. Thank you. Thank you. Make sure to grab a notes pack. Okay, so I'll go on to the last one, and then I'll give you your exit ticket and homework. So for the average rate of change for 4x, I think this is supposed to be r of x. This is a typo. For r of x on 12 to 15. So again, the 12 to 15 is our x values. We're picking the 12 here, the 15 here, and we're calculating the average rate of change. Delta y over delta x equals, the y values are 30 and 10. The x values are 15 and 12. So you have 20 over 3. Now we do want to get a unit rate because we have to use the unit rate for interpreting. We wanted to have that per 1 in the bottom. So I can't leave it as 20 over 3. So this is going to simplify to 6 2/3 or 6.6 repeating. All right? So it says, interpret average rate of change if R of X models accumulated rainfall in centimeters. Okay, so R of X is the rainfall in centimeters given on a given day, X hours after midnight. So that X is the hours after midnight. Did you raise your hand? 20 divided by 3 gives me 6 2/3. Again, I need the unit rate to do the interpretation. So for the interpretation, I'm going to write, let's see, for each. I want to start out with for each. So for each, what's the X? The hours, right? So for each hour after midnight, and then we write what's happening to the Y value, to the R of X. What happens to the R of X? What is R of X? The accumulated rainfall. The accumulated rainfall increases or decreases? What does it do? Is it increasing or decreasing?
Oh my.
It's positive, so it's increasing by 6 2/3 centimeters. And that's it. Okay, so just want to write in the bottom a generic for interpreting. If I can spell interpret. Interpret. For each, and then you're going to fill in 1 unit of X, whatever it is. Okay, you're going to describe it. Blank. Fill in the F of X info. Increases or decreases by, and then say how much your slope, rate of change. Okay?